So when we get into Chapter 5, Section 5.2, we start looking at things from the perspective of real world, which is what we do in statistics. Section 5.1 just sets you up to be able to understand how to find the probabilities that you're interested in. But Section 5.2 applies that to real world situations. So I'm going to give you an example. And that example is that IQ scores are approximately normally distributed with a mean of 100 and a standard deviation of 15. So if we were to look at a sketch of this distribution, we would have 100 in the middle, then 115, 130, 145 going up, 85, 70, and 55 going down. So that's showing you have a mean of 100 and a standard deviation of 15. So if I wanted to talk about finding the probability that someone had an IQ less than 120, we don't necessarily have a table for every possible mean and every possible standard deviation. So again, before you had calculators, you could take that 120, convert it to a z-score by doing 120 minus 100 and dividing by 15. And getting 1.3 repeating. And then you could find the probability that Z was less than 1.33. Looking at this from the perspective of where it would fall on the distribution table, 120 would be somewhere here, and then all of this area to the left would be shaded. So I know it's going to be more than 0.5. And like I said, you could change that to a z-score and find the probability using the z-table. Or, or you could use your calculator. And that's what Section 5.2 does, is instead of having to convert everything to z-scores, it allows you to find the probability that you have an IQ or an X value that's less than 120 using normal CDF. Your lower bound would be negative e to the 99th. Your upper bound would be 120. Your mean would be 100, and your standard deviation would be 15. So if I looked at it from that perspective, on my calculator, I could do second vars, go down to 2, use negative e to the 99th as my lower bound, 120 as my upper bound. But here, instead of the mean being 0, I would need to put in my mean of 100 and my standard deviation of 15. And I get 0.9088. So that's what section 5.2 allows you to do. It allows you to find a normal distribution probability given any mean and any standard deviation. So if I want to look at another example, let's say salaries at a firm are approximately normally distributed. With a mean of 48,000 and a standard deviation of 12,000. So again, draw my normal curve. My mean would be 48,000. And then I could go up the 3 standard deviations and down the 3 standard deviations. So I'm going to find a few probabilities. I'm going to look at the probability of having a salary that is less than 30,000. I want to look at the probability of finding a salary that is greater than 75,000. And I want to look at the probability of having a salary that is between 35,000 and 80,000. So for the first one, draw my normal curve, 48K in the middle, less than 30 would be an area to the left. So I'm going to use normal CDF, negative e to the 99th, 30,000, 48,000, 12,000. So if I go to my calculator, second vars 2, negative e to the 99th, 30,000, 48,000, 12,000, and I get 0.0668. So if I went to work for this firm, I could say that there's about a 7% chance I'm going to make less than $30,000. Looking at the second one, the 75,000. I would use normal CDF. 75,000 to e to the 99th, 48,000, 12,000. So if I put that in the calculator, second power is 2. This time I'm 75,000. Second natural log, whoop, that didn't work. Second natural log, e to the 99th. Make sure you close your parentheses. And I get 0.0122. So, looking at that, it looks like there's only about a 1% chance with a probability of 0.01 that I would make more than 75,000. And then for the third one, I'll go from 35,000 to 80,000. So I'm going to use normal CDF. 35, 80, 48, 12. $35,000, 80,000, 4812, 0.8568. So, if I was marketing this job and I was trying to hire someone, I could tell them that there's about an 86% chance they would make between $35,000 and $80,000 at this job. So that's just one example, and you'll have a lot of others where you can use what you learned about finding probability on a normal curve from section 5.1 to finding probabilities that are normally distributed with any given mean and any given standard deviation. Now, there's nothing to say that you couldn't go back and take each of these problems and convert to z-scores first and then use what you did in 5.1. That is perfectly acceptable, but it's not required, not if you're using your calculator. And that's the end of section 5.